Hello students, welcome back in the last and final lecture of the periodic classification of the elements. In previous lecture we discussed the modern periodic table. I think I have told everything about that. A few things I forgot to tell are this is the modern periodic table. The elements on the extreme left are metals. A line is there: boron, silicon, arsenic. This is a layer, zigzag layer of elements having characters of both metals and non-metals, they are metalloids. Germanium. This is the layer of elements having characters of both metals and non-metals. On the extreme right there are what we call non-metals, and the elements in from group number 3rd to group number 12. Group number 3rd to group number 12 are called transition metals. Why they are called transition metals? Because they show transition from metallic character to non-metallic character. They show transition from metallic character to non-metallic character. Here the metals are there. When we go from this to this, the non-metallic character increases. Now one thing more, these two we can say horizontal lines are placed outside the table. Why they are placed outside the table? Because if they are placed over here, their position is atomic number is 58. This should be placed. Means its position is here, but it is placed outside. If they are placed here, then they will make this table deformed. The shape of the table will not be good. That's why they are placed here. In today's lecture, we are going to discuss the trends in the modern periodic table. What we are going to discuss, as I have already told you, that when we go from left to right in a periodic table, the metallic character decreases and non-metallic character increases. This is trend. In a similar way, when we go from up to down in a group, what changes take place? These are the trends. In this chapter, in this lecture, we are going to study about the trends. First of all, we should know the common things that are necessary to understand the trends. First one is atomic size. This is also your first trend that we are to study. Atomic size. This is the structure of the atom. This is nucleus. Here protons and neutrons are there, and electrons revolve around this. Here in the shells. This is the structure of the what we call atom. This is the atomic radii. From here to here, outermost shell to the center of the nucleus is atomic radii. How this radius or atomic size changes when we go from from left to right in a period and from up to down in a group. This we are to understand. One thing that is common in all type of trend is when we go down in a group, number of shells increases. This is number of shell increases. This is nucleus, a first shell for hydrogen. One electron is there, one proton is there, no neutron is there. Okay. Then if we look at lithium, two shells are there. This is nucleus, protons, neutrons. First shell which contains two new electrons, and this one contain one electron. Then, so if we talk about the sodium, its configuration is 281. It is having three shells. As we move down in a group, number of shells increases. This is what you should know before studying the trends. But when we go from left to right, for example, we are here at sodium, the configuration is 281. Then we have discussed its shells. Then magnesium. The magnesium will have configuration 282. It means number of shells remain same. 281 means 3 shells are there. 3 shells are also there in magnesium. What is the difference between these two? The difference is the difference of the number of electrons in the valence shell. It means when we go from left to right in a period, valence electrons, number of electrons in the valence shell increases. These two things should be kept in mind while studying the trends. Now let us discuss the first trend, that is valency. First is valency. Valency is the combining capacity of an atom or element, we can say. Valency. This depends upon the number of valence electron and depends on number of valence electrons. Number of valence electrons. Okay, valence electron, it depends upon the number of valence electrons. For example, if we are studying the first group, hydrogen, lithium, sodium, potassium, they all have one electron in their valence shell. 2,1, 2,8,1, they all have one valence electron in their outermost shell. Therefore, their valency will be plus 1. They can easily donate 1 electron. Okay. Therefore, valency, when we go down in a group, the valency of the elements remains same. Valency, there will be no change in valency when we go from up to down in a group. But when we go from left to right in a period, lithium, then is beryllium, then is boron, carbon, nitrogen, oxygen, fluorine, neon. Here the valence electron is 1 and here 2, 3, 4, 5, 6, 7 and 8. The valency of first element is 1, its valency is plus 2, its valency is plus 3, then 4, then it starts decreasing. When it is more than 5, we have to find out the valency by subtracting the valence electron from 8, that is 3, minus 3, then minus 2, then minus 1, then again 0. Therefore, when we go from left to right in a period, valency first increases from 1 to 4, then decreases 4 to 0. This is a trend that you should know. This was our first property or first trend. Then let's come to the next, that is atomic size. Atomic size, I have already told you what the atomic size is. First of all, let's discuss about the group. We are talking about group. First group, let's take the example of first group, that is hydrogen, lithium, sodium, potassium. 1, 2, 1, 2, 8, 1, 2, 8, 8, 1. What are the difference between all these? When we are going down in a group, the number of number of shells goes on increasing when we go down in a group. Number of shells are increasing, therefore their size will also increase. Number of shells are increasing, therefore their size will also increase. Therefore, when we go down in a group, the size increases. And what about the period? This was the trend in a group. And let's talk about the period. If we talk about the period, let's take the example of what we call second period. That is lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and last neon. Its atomic number is 3. Then and valence and its configuration is 2,1, and atomic number 4, configuration 2,2, atomic number 5, 2,3, atomic number 6, 2,4, atomic number 7, 2,5, atomic number 8, 2 6, atomic number 9, then 2 7, then 2 8. What is common in all these? When we are going from left to right, the common is they all have same number of shells. They all have same number of shells. And what is the difference? The difference is of the number of electrons. If the electrons are different, therefore protons are also different. It means when we go from left to right in a period, there is increase in number of protons, but shells remains same. If the proton increases, means more positive charge is there. If the more positive charge is there, they will attract the outermost electrons more effectively from the previous one. Therefore, when we go, if they attract more effectively, the size will decrease. If they attract it more effectively, the size will decrease. Therefore, when we go from left to right in a period, the size decreases. Size decreases. Okay. Now let's talk about the next trend. What is that? Metallic and non-metallic properties. Metallic and non-metallic properties. Metallic and non-metallic properties. First of all, we should know metallic and non-metallic properties. On what factors this character depends. Metallic character depends upon how easily an element can release its outermost electron. If it can release the outermost electron more easily, it means more metallic it is. If an element we can say gains electron more easily, then more non-metallic it is. Now let's take the example of first group: hydrogen, lithium, sodium, potassium. 1 2 1 2 8 1, then 2 8 8 1. Number of shells are increasing as we going down in a group. If number of shells are increasing, it means electrons are going apart from the nucleus. The distance between the outermost electrons and the nucleus is increasing as we go down in a group. If the distance is increasing, the attraction will definitely decrease. If the attraction decreases, means we can easily remove the electrons. Therefore, metallic character increases while we go down in a group. But when we go from left to right in a period, as the example is written over here, we find that number of shells remain same, but nuclear charge increases from one element to another element as we go from left to right in a period. If the nuclear charge, it means attracting power increases, it will attract electrons more effectively. Therefore, non-metallic character will decrease, but non-metallic character will increase. Up to the end, these will change into totally non-metal. These are the non-metals. Means if we move from left to right in a period, metallic character decreases, but non-metallic character increases. This was all about the trends that we are to study in this chapter. Now let's discuss some questions with you which are given at the end of your end of the chapter. The question number 1 is: how could modern periodic table remove the various anomalies of the Mendeleev's periodic table? I have already discussed position of hydrogen, position of isotopes, and what was more anomaly, position of hydrogen, isotopes, and wrong arrangement for he placed cobalt before nickel, Mendeleev. These all anomalies were removed. This the answer I have already given you. Then next question is: name 2 elements you would expect to show the chemical reactions similar to the magnesium. Chemical reactions depends upon the number of electrons in the valence shell. Number of valence shell electrons will be same in the group number 2. Magnesium is in group number 2. Therefore, all elements in group number 2 that is calcium, strontium, barium, radium, beryllium, they will all show the same chemical properties as of the magnesium. Next the question, three elements that have single electron in their outermost shell. Outermost shell has 3 electrons. Sorry, how many electrons are there? Single electron in the outermost shell. Single electron means if the value shall contain 1 electron, single electron, it means group number 1. We are talking about group number 1. Then you can write the name of the lithium, then sodium, potassium, rubidium. You can write all these over here. Then two elements that have 2 electrons. 2 electrons, if we are talking about 2 electrons in the outermost shell means group number 2. Group number 2, that is beryllium, magnesium, calcium. You can write all. The next question is three elements with filled outermost shells. Fully filled. Fully filled means this is the group that is fully filled. This is group number 18, that is inert gases. You can write their names, that is helium, neon, argon, etc. The next question is question number 4. Lithium, sodium, potassium are all metals that react with water to liberate hydrogen gas. Is there any similarity in their atoms of these elements? Let's check. Is there any similarity? He is talking about lithium, then sodium and potassium. Atomic number 3, atomic number sodium, atomic number 11, then 19, configuration 21, 281, then 2881. What is common in them? They all have same number of electrons, that is 1 electron in their valence shell. That's why they all show the same characters, chemical properties. Helium is an unreactive gas and neon is a gas of extremely low reactivity. What if anything do their atoms have in common? What common thing they have? They all have fully filled outermost shells. Means their outermost shell is fully filled. You cannot add any more electron to their outermost shell. This is common in these two. In the modern periodic table, what are the metals among the first 10 elements? Metals in the first 10 elements. 10 elements: hydrogen, helium, lithium, beryllium. We are talking about up to neon. How many metals are there? There are just two elements which are metals, that is lithium and beryllium. These are the two metals, and these all are non-metals. As I already told, that on the extreme left side of the periodic table are metals, on the extreme right are the non-metals. There is one zigzag line that are metalloids. And last one question, by considering their position in the periodic table, which one of the following elements would you expect to have maximum metallic character? Gallium, Ge. First of all, find them out. He is talking about these elements: gallium, germanium, arsenic, selenium, bromine, krypton. Yes, he is talking about these elements. What is he asking? Which is having more metallic? More metallic. When we go from left to right in a period, the metallic character decreases, but non-metallic character increases. Therefore, if we talk about all these, gallium would be the most metallic out of these elements. This was all about the chapter number 5, that is periodic classification of the elements. In the next chapter, we will meet with a new chapter. Next lecture we will meet with a new chapter with new zeal. Until that, goodbye.